we decided not. Sounds like we decided not to do
Oh,
that. So
yes.
if you want to hear something from me, you're not gonna hear.
Well, it's not going to be like a formal meeting presentation, but you know, we're trying to get some members, and we're trying to have people have participation in electing officers, and it's better than having 10 people vote for us.
No,
And
I'll be there, and anybody that's interested in Tapper should definitely
yeah, and we can
attend,
answer
make
questions.
make suggestions. I'm looking
Yes,
forward to hearing all
yes.
inputs. Okay, back to you, Dave.
Yep. So I'm the president of Tapper and Paul is the vice president. So you got two of the officers uh, here. Hello, Nathaniel.
Hi, Dave. How are you?
Just fine. You're next on the list. So go ahead.
Great. Things are going along as usual, continuing to try to keep all the projects going. I think it's moving along. I think Elmer is going to be visiting on Friday and working with me and with Jonathan on some VLF stuff. We had a nice call this afternoon with Dave Witten and Majid and Christine Zagziski and my wife about the magnetometer. So that was going well. And yeah, just trying to keep everything going. So back to net.
Very good. Next on the list is Clint, K7OEI. Go ahead, Clint.
Just random radio stuff here. Just so nothing specific, so I'll send it back.
Okay. Next on the list is Dave H, W6OQ. Go ahead.
Yes, good evening, everyone. Yeah, I'm here. I'm trying to see what to learn. That's about it. Thanks.
Next on the list is Dave Julian, WB9YIG. Go ahead, Dave.
Good evening, folks. Had some fun over the weekend in the last couple days. Picked up a TS 570 at the Hamfest that was free. It'd been hit by lightning, and so I was trying to work on a 590, so I thought I might get some parts out of it. Got it fired up and actually found some problems, and I think I can get it working for about $50. It blew the protection, little glass protection things across the antenna terminals, welded the transmit receive relay and took out a coil. But other than that, it seems to be working.
Well, sounds good.
So back to net. I'm just having fun.
Yes. Next on the list is Dave Witten. Do you have a mic, Dave?
I've just been trying to clean up some stuff about the magnetometers, work on a way to install it more easily. And well, that's been more than enough for me lately. So that's it.
Okay. And then next on the list is Elmer in 3AGE.
Good afternoon, all. Yes, I will be visiting Nathaniel and have VLF power supplies, and I also have a new battery plus minus power supply that I finished assembling yesterday. I'm assembling another amplifier, which I will complete tomorrow, hopefully, and we will be able to do quite a bit of testing in a very short period of time. But hopefully, we could come up with something that is that will work with HF and VLF and not cause mutual destruction. Back to net.
Very good. Next on the list is Paul Elliott, WB6 CXC. Go ahead, Paul.
Yeah. Evening, everybody. Well, let's see. I just completed my bi-monthly migration back down to Occidental from Friday Harbor, so I'm still sort of settling in. I've been working on the DV8, the RX80 888 replacement of sorts, working with Dave Witten. I am trying to get all the IOs sorted out. Want the thing to behave. Don't want to require a new driver for it, or at least, very few variations. So I've been working with Franco and looking at source code for the current driver just to make sure I got all the IOs sorted out so everything's on the same pins as it used to be, only simpler. And so I'm again working on that. Other than that, if again, I'm really happy to see the doctor get the whisper sound up and running on St. Helena. And if I'm set up to provide 2 more whisper sonds plus filter combiners, instantly. If anybody wants to put up another one somewhere, I can support that. Other than that, just general stuff, not too interesting. And back to net.
Okay, very good. And next on the list is Christina, KD8OXT.
Hi folks, how's it going?
Hello.
Let's see. I'm just getting through some grant writing today. One fun thing that's coming up is I'll be convening a science session at a music show in January. We're going to do a sonification session at the NAMM show in Anaheim. So I'm looking for presenters in sonification, and hopefully some of our friends from the HARP project will be going to that. And that's my science updates for the moment. Back to net.
Very good. And next on the list is Scott, N5TNL. Go ahead.
Hey guys, nothing to report. Back to it.
Okay. And then we have Tom, N5EG. Go ahead, Tom.
Oh, good evening, everyone. Just a little update here, if I can get it up on the screen. I've still got about 40 or 50 wires to go, but this is the 4-channel receiver so far. And you can see the big connector up here. That's the where the FX10 plugs on. There's 4 RF channels. There's a frequency reference and a pulse per second, and an external power input if needed. And this is 16 bits of GPIO. So it's making progress. Still has a little bit of work to do. The holes are sized for number 4 or M3 screws, and the board's about 6 by 7 right now. So that's it. Back to the group.
Very nice work, Tom.
That's exciting, Tom. Thank you.
So, except for Rob, who said he was going off to get some food, and I'm sure he'll talk to us once he gets back.
I'm actually available right now.
Okay.
So,
do you want to give an update on what you're up to?
well, I mostly, as I said, been working on the server software, which isn't related, but I did spend some hours working by email with Tim Duffy on the K3LR installation, which is working well. I think he has site problems. The RF noise levels are I think maybe 10 dB or more too high, above 10 megahertz. 10 megahertz is okay, but to compare his site with George's, who has a similar antenna, George's characteristic decrease of background noise level with increasing frequency, and that doesn't happen at K3LR. And couple minutes, I'll be able to show you an example of the comparative spectrums. But also the spot counts also reflect that there's problems at higher frequencies at the K3LR site. I mean, one of the problems is, of course, inherent to it is the superstation, and when the transmitters turn on, he's got a bunch of S9+6 signals, which actually it's not that hard to deal with them. You have to just turn off the AGC and go down to fixed AGC at 0 dB gain. Stops all the overloading, and you still get lots of spots. So I think that there are other sets of problems. Anyway, I turned the AGC is back on, and let's see if I go back in here, maybe I can show you guys what's going on. But I have to log into the meeting on my desktop computer to be able to share things with you. Anyway, that's the major task for me as I was working with Tim. And I'm on from my desk.
Now we
So
have
I'm gonna,
2 views of you. You might want
I
to
got
mute.
2 views of me. Let me hang up this one and I'll.
Yeah. And you need to unmute, Rob.
I know that. Yeah. Okay. So here's an example. There's a two views, and I present this to the group because I believe as we go into deployments that we're going to have to deal with this at most sites. Well, not this, but Tim is an example of each site is unique, and you're going to have somebody is going to have to shepherd these people, and it took me away from my work on software to work with this. It's interesting to me, but we need we need domain installation domain experts, and I'm looking forward to us having them. Let's see, where are their screens? Here's uh, here's an example. Here, where it goes there. Okay, yeah, you see that on the left? You can see there's K3L. This is a midday. I don't know, it was something like, what was it? Pacific time, 11 o'clock. So it was 2 in the afternoon on the East Coast. And these are the spectra that almost calibrated, same range. And you can see that they're both tuned to WWV, 10 megahertz. So you can see that George is receiving at a level of minus 79 dBm for WWV. Now, Tim isn't, he's 100 miles away or something, 120 miles away to the east, but there's a almost 20 dB difference, 18 dB difference in signal level between the two. So but more important than that is if you look at the slope, the red line, this is a feature of the K9Q web receiver that is an extremely valuable tool in analyzing the performance of a site, is to turn on the max, it's called max hold, but it's really a hold feature, and to select the minimum level, a checkbox, as you can see in the left. And the red line indicates basically what the noise level is over the last, this is maybe 10 minutes. What's the minimum in each one of the, I guess these are, the bins are 40 kilohertz wide. So bins where there's, the middle of a band, there's always a signal there so that, the minimum never goes down to the noise level. But you know, if you look at it, it's not so much the absolute level, but you can see George's goes down as you go up in frequency, whereas uh, K3LO doesn't. And then if you go in and compensate for the differences in gain between the two sites, um, that it looks like that level above 10 megahertz, the minimum levels are a good 10 to 12 dB higher than those on the right. So if you, and that's compensating for differences in gain, you know, RF gain and so on. If you, so this is the kind of analysis that I think has to be done if you want to get the most out of your receive site. Now, this could be ingress. It could be these noise that we're seeing on the left could be unique to the DXE and the 888. Or it could be a site problem. It's propagated noise, in which case this is something that's affecting all of his receive channels. And it
What
would,
is the antenna? What is the antenna on each of these?
each of these is the DXE active vertical. This
Okay.
is the one that we're specified as part of the DAISY deployment, and the one, of course, that Tim manufactures and sells. So they're identical installations. George has worked hard to get his DXE down to reach this level of performance, um, where it pretty much matches the performance of the SAS. They're pretty much the same at this at George's, but it took George a fair amount of work in order to achieve that. You know, chokes and filters and all that kind of stuff that had to go in place. So it's you know, these differences I think are real, and you know, if you want to really compare or optimize the performance of the network we're just receive network we're deploying, I think they have to study the performance of the sites as I started to do there at. Now, the other way to quantify the difference is to go look at the spot reports. So if we go here and look at the top spotters, this is a top spotters query, and I've restricted it so that it just gives me the, you know, most relevant sites, right? This is K3LR, George's. These are all the same antenna. Now, of course, they're separated by hundreds of miles. So, you know, you can see that you would expect, in general, our experience is the farther west you go, the fewer spots you get. But in this case, you can see over the last 24 hours, this is 24 hours, that the K3LR site has significantly poorer sensitivity, and at the most relevant, you know, well, in you know, the number of spots is somewhat about the same, the raw spots column, but you have, you know, almost, what is it, 18, that's 1900, there's almost 10% fewer spots at K3LR than at other sites. And we would expect it to be matching most closely. K3LR, I think, is closest to Nathaniel's. And, you know, it's significantly less sensitive. So these are the tools that are available now to us as we deploy sites, receive sites, and gain some insight into how well they're performing. And I think that these metrics reflect on the quality of the WWV reception as well. It's not like you know, this is these metrics are relevant only to WISPR. I believe they're relevant to others. Anyway, that's my quick report, if I can stop sharing, unless someone has a question about this. So back to Nat.
Okay, I will call on two people that have just joined us. I believe only two have. One is Dave McGaw and one HAC. David, you have any comments?
Good morning, everybody, or morning somewhere. I guess it's morning, UT. Yeah, not too much to say, but yeah, it's we're getting rain here, and yeah, my problem is I have a rehearsal Monday evenings, so I get here late a
Oh,
lot of the times. We got Christmas revels, if people know what that is. We are number 2 site after Boston. Unfortunately, it's last year, but we're doing a Scottish show, so I have to be in it. And continue to work on our satellite ground station. Um, but other than that, just listening to the bands, I guess. Um, Interesting propagation going on. 25 megahertz WWV's been actually quite strong lately, which I was surprised because it wasn't over the summer. But vagaries of what's going on up there, and that's why we're here. So back to net.
okay. And the other person that came in after Rob started talking is Jonathan, KC3EEY. Any comments, Jonathan?
Hi, everybody. Yeah, I got home late. But anyway, I noticed that Elmer is on. Elmer, I would like to use some of the main discussion to discuss our plans for Friday testing and everything else that definitely would benefit to be discussed. So we have a good idea going forward. So we're prepared and we're the most efficient on the Friday. Also, Nathaniel. Well, looks like Nathaniel isn't there, but it.
I'm here. I'm just in the background setting up a radio, but I'm here.
Oh, okay. Well, I also noticed that Christina is here. I don't know if we should fill her in about the discussion last week regarding with the charrettes, the adding of VLF data ingress capability to the server. Obviously, it'll be a fairly complex project because it's a different system, but we could use some of the general discussion to cover just some of the higher level main points that I was discussing with Bill. Other than that, that's all I have. Back to the net.
Okay. Well, I think I've called on everybody on the list. Has anybody joined since the last two? And if not, we should be open for general discussion. Now, Nathaniel had an idea that if there are some work specific things, we can use breakout rooms. And depending on whether it's of general interest or a work specific issue, we'll keep the general interest here on the main site. And then I encourage people to have breakout rooms if you need them. So
I have one just to be, may run off entirely here, but
okay.
I did talk with Michael, and Gary had said that they wanted to have a whisper sonde in North Dakota, and Michael will be up there next week, and he could install a whisper sonde in Fargo. It would be convenient for him to do so. If a package is ready to be and could arrive there by next Wednesday, 10 days from now. So I don't know who's responsible. I guess it's Gary is
And
responsible for that. But if someone, if you want to get one installed and running up there, he has a site that is distant from the receive site, so this won't affect the receive site.
yeah.
A separate place.
So, Paul, this would be one
It
for you to.
well, actually, it sounds like it. Uh, Sounds like we're thinking about this would be one of the ones that Nathaniel has
Yeah,
the
yeah, yeah.
setup, correct? I mean, that would
Mhm.
include the
Yeah.
antenna and Bodnar and kind of the whole works. And
Yes,
if um,
I think
I can provide some of that, but it sounds like if Nathaniel, if you've got the entire package and that
Yeah,
works
we
with your plans.
we do. I don't know that we'll be able to get it ready to get there by like, next Wednesday. I mean, we might, but it's going to be a lot of scrambling, and I'm already scrambling with a lot of things.
Oh,
Um,
I thought you don't have antennas. I mean, you need
well,
everything, including antennas and such.
right now, I mean, I've ordered a lot of stuff, but there's also a lot of like little detailed. So I have all the whisper songs, I have the filter combiners in stock. We ordered the antennas. I don't know if they've arrived yet. Um, so I think there's a lot of little details that haven't been all
Okay,
pulled together.
Bunch
okay,
of SMA cables and the whole deal. Yeah.
Yeah, yeah. So we're still,
okay,
yeah, we're not quite ready for that.
okay. Well, I told them I would
Yeah.
communicate the opportunity to the group. So
I have something, Nathaniel, that this is real quick. Starting probably next month, in Friday Harbor, the local county ham club is going to be working with a high school STEM teacher, the STEM center, and he just got his ham license and he's, um, you know, and I've met some of the students, at least last year's students, and there's some interest. I'm just wondering if there's something, um, that we could help them with as far as ham size stuff at the local high school. Would you
Which
be interested in, you know,
which one is this?
this is Friday, the high school at Friday Harbor.
Oh, yeah, okay. And what are you thinking of for there?
Well, I'm not entirely sure yet. I need to spend some time with them. It's been a long time. This was mainly set up by some of the other hams, but I've injected myself into that. So I'm not going to know the level of or direction of their interest just yet. But as this develops, I think it could be a really nice way for them to get involved.
I agree with that.
So I'll just follow up with you once I get a better idea of what it is they're actually interested in doing. But it's something that I'm excited about because we need all the help we can get getting young people interested in technology
I agree with that.
and radio, and if it's ham radio, so much the better, but anything that there is good, I think.
I agree with that.
Okay, I'll work with you when I get closer to knowing what we want to do.
Sounds great.
Thank you.
So Dave, do you want like the VLF discussion to go into breakout room 1 and then have
I'm
this other
just
area?
stating that this is a procedure change that we're talking about,
Yeah.
and that if it's informational for the full group, that's good. But if it's not, it's better to be in a breakout room.
Well, I think we're going to be talking a lot about exactly what we're doing at my house on Friday with testing the VLF stuff. So, I mean, maybe what we can do is we can say, if anyone who's interested in what we're doing with the VLF stuff can come join us in breakout room 1, and anyone who wants to talk about the other parts of the project, they can just stay here on the main discussion.
I will mention that Phil has joined us. Phil, do you have any comments?
Not really. I just came in from working on my car. Not much to report this week.
Okay. I just wanted to acknowledge you as another
Thank you.
participant. So, we've gone through the list. And Nathaniel, I'll let you decide what you want to do with your work party.
Yeah, why don't we and anyone can follow us. So let's just have the VLF discussion in room 1, and then anyone who wants to hear about VLF can go join room 1. People can hop around themselves, and then anyone else who wants to stay here. Does that sound good? Jonathan, does that sound good to you?
Yeah,
All right.
yeah. That sounds good.
All right.
It
And Elmer's already over there.
it looks like that Christina had to leave.
Yeah.
Okay.
Well, I'll get caught up with her though.
All right.
Yeah. Great.
I have a question for Paul here. So, were you? I do know that Michael's going up, but I don't think you're going to make a package to him in time to go this trip. If he's going within a week.
Wait, are we talking about Whisper Sound?
Yes.
Again, I think I can provide 2 pieces of that, and
Yeah.
that's not, that's the combiner and that's the Whisper Sound itself. But for a full setup, he's going to need a Bodnar or equivalent.
Yeah.
He's going to need a bunch of cables, and it would be nice, Rob, to have Raspberry Pi hooked up to that for remote access. And so I don't have any of that other stuff. All I've got are the 2 pieces of hardware that that I build. I do have those with me. I brought 2 setups down with me here and to California, and I have
Okay.
another 2 up in Friday Harbor, just sitting on a shelf. And
Well,
I've got more I can make if somebody actually wants them, but I've got 2 immediately available. But that's he's going to need more than that to get something up and running.
Yep. He would be here, but as I understand, he's working. So in he works 10 to 12-hour shifts when he works. So I don't know. I think it's tomorrow that he's working, but not tonight. But anyway.
I mean, I think, another if there was another time, next month or whatever, I think that, one way or another, we could probably get a package ready for him, but
yeah,
but not yet.
Yeah.
Once Nathaniel gets all the other stuff that he's ordered, maybe he'll be set up for, quick deployment as the opportunities come up. But that's not here yet.
Yeah.
Ascension Island, I'd love to see one out there too.
Yes.
But again, however we can, and at some point, I know Rob and I would like to maybe get reimbursed for some of what
Yes.
we've put out there, on consignment or free or whatever. It does add up in the over the long run. So if there are ways to get reimbursed for at least some of these, that would be kind of nice.
I guess make a proposal to Nathaniel or
Yeah, I mean, we've talked about it before, but at some point.
Yeah.
Rob, I'm not trying to speak for you, but I assume that's probably accurate.
There are some pieces of equipment here, for
Yeah.
instance, at my house, that nobody's never even knew who they really belong to, but I'd be happy to reimburse somebody for if with a little warning.
Yeah.
Uh,
Dave has one of your whisper sounds.
A Whisper Sound, or is this like the old Beacon Blaster thing?
it's the old Beacon Blaster one.
Oh,
Okay. if somebody actually wants to run that, I mean, it runs fine. I mean, I'll donate that one to the cause. I don't really need it myself.
Okay.
It's just the news stuff, you know. The university paid me for, you know, a good number of them, and that's, you know, I was very grateful for that. That helped a lot. But um, the ones that are actually out in the field now, I don't. I think there's one person who's actually bought one, and the rest are, um, you know, out there with the, you know, I'd rather have them there than in my garage, but you know, at some point, I should talk with Nathaniel about this, I guess.
Well, if it's a, you know, if it's a cash flow thing, I can,
No, I have,
I'm not
of
comfortable having things that I didn't pay for. Uh,
if again, if it's a beacon blaster, that's a donation to whoever actually wants to plug it in and use it.
Yeah.
That's absolutely fine with me.
We
No, guys, I am not hurting in any way,
yes.
shape, or form.
okay.
And if you think, if I sound like I am, you have my permission to kick me in the ass, because I'm not hurting.
Well,
Thank
Michael
you.
and I suggested Dave put the blaster at his house because both of us wanted to receive, and we're all
Well,
three in the same community. So
is it running now?
yeah,
Yes,
Oh,
yes.
wonderful then. No, great.
it's been running
Please.
steadily for a long time.
Oh, good to hear. Okay, good.
So
I don't know how long, since the eclipse.
Okay. Yay for me and my design. Good.
Mhm. It blinks. It's got an awful bright green light on it or whatever.
Yeah.
Sometimes I'm tempted to add a little resistor in there.
I put a piece of masking tape over it myself. How are you?
It's reassuring. And
Yeah.
so let's see.
Hey Phil, ARDC. I don't know if you've heard. There's a STEM center at the local high school in Friday Harbor, and I pointed the teacher at the ARDC website.
Oh,
So
good. Okay.
yeah, I mean, I told him I don't, you know, I don't have any pull or anything, but he seemed interested, so maybe he'll put a proposal up there for you. I don't know.
Okay.
All right, this is too quiet.
Yeah, we're all quiet.
Rob's
Was-
still there in the dark.
Did
I don't
somebody
know
mention
whether I probably have already mentioned this to you, Rob, but I at least I'm not certain whether it it works the way you're setting up the Proxmox with a what you call it the way you're doing it anyway. And I think I found some problems doing it with the container, but you're not doing that. But there's a way to assign a fixed name for a device, you know, that's linked to a serial number um, on the um, for the magnetometer, and it's convenient for me, and it might be convenient for you if we had that always assigned. You know, I can just, but you could move it around, but I can use you know, an arbitrary but not otherwise mistakable um, device in slash dev uh, as the USB 2 port that supports the magnetometer. Um, if we would, if we could just, you know, agree on how to do that. I don't know if that,
I'm open to anything there. There's nothing you know, I don't, I work off of, you know, config files, and in terms of finding the 888s is the only thing I find on the USB bus. So that's found through its serial number, or if there's only one, there's no serial number needed, which is the case at most Davies sites. So I think you go ahead, do whatever you want. I'm sure
Yeah.
we can work around it.
Well, I just, you know, if I use, if I have a default port of like TT, you know, /dev/TTY ACM 0, somebody else is likely to have grabbed it.
Yes.
I have it in, you know, it's configurable from either the command line or from a config file, but it would be better if you didn't have to do that at all. And, you know, there's an arbitrary one that nobody had ever used, like TTY PSWS mag or something like that, that is highly unlikely to ever appear on any of these machines on their own. And I can, if I open that, it can get mapped to, you know, whatever's available, you know, where
Yeah.
the device is. And it just seems like one less fidgety thing to have to fight, you know, configure.
Okay. Well, that's fine. As uh, I try to set up things with defaults built in, the default value, so that you don't have to enter anything, except the absolute necessary ones, like the you know, the reporter ID has to be unique across the whole world. So things like that, there are no defaults, but everything else is defaulted inside my code. So most of which has it can be overwritten by putting a statement in the config file. So that's the strategy. There's a, you know, there's a default value inside the code that can be overwritten if that variable is defined in the config file. So, that's, Phil will be happy to learn that I've all the server stuff I've implemented in the last couple of months uses, I think, all of the Linux standard stuff. They're all being created as Linux services that you do system control, start, stop, and so on. So I'd hope that you might consider doing that, Dave, if you can. It's Chat or Claude, or make it really easy. They'll create the wrapper scripts for you and the service files.
Are you putting all your files in the standard places?
Well, all of the server files are going to standard places. I haven't rewritten the client side yet, but I will over time.
Okay, good.
Yeah, so it's
What are you considering standard places for configuration files?
Oh, there's a Linux standard. You know, configuration files go in /etc. Databases and data files and so forth go in var lib package name.
Sure.
Stuff like that.
Yeah.
Yeah. Okay. I just yeah, I get that.
Yeah, I try to follow that in KNIQ Radio.
Yeah. Yeah, it's just yeah.
Yeah, the server code, which you never will see, Phil, is, I think you would really like the way it's now implemented, but you'll never have occasion to look at it.
All right.
So,
Can I make a folder called /etc magnetometer or something?
Yeah, yes, that would be the exact, yeah, something like that. Put your configs in there, and if it's there, you know, in my case, and I think well, it depends on your programming language, but for Bash, you just put in, you know, Bash variable declarations in the etc whatever.conf.
In general, you should have, if you have a bunch of config files, you should put them in a directory, etc/directory named after the package name.
Okay.
And then have whatever you want under
Package
that.
name. Okay.
Yeah.
All right, because there, you know, there are other ways that I see it done sometimes, and sometimes it makes you want to cry, but
This makes it much easier to maintain machines when you follow this convention.
And I'm all about that.
For example, if you want to back up the most important parts of the machine, you generally grab everything in /etc, right?
Sure.
Yeah. Everything else can either be, reinstalled or reloaded, but the stuff that's site specific, you really want to back up.
Sure.
Yeah.
Yeah. No, no argument there. But these things are generally now being regarded as system services rather than user space runtime things. You're doing it all with System D and
Right.
yeah, that makes it clearer to me.
Yeah, it's also best to avoid having to modify or configure the service file. Try to configure things in a config file instead and have the service file read them or include them out of like an environment file. It's not always possible, but it's a good idea.
Yeah, I think that's right. I may need to put in, well, if it's running as, if it's being run by System D, then I don't have to worry so much about UDEV rules and things like that either.
Well, UDEV rules are something separate,
Yeah,
right? I mean, there may be UDEV rules you have to install also. They set up all the permissions and the device names and so forth when a device is plugged in.
yeah. Well,
That
that's
usually only has to be done once.
Yeah, well, that's actually how I was mapping this arbitrary alias for the USB TTY device to get it out of the way of other applications, and so it wouldn't move around.
I have a message for Rob. Can I?
I'm
I just
here, so
I wanted to let you know, you are not getting any data from my rack number right now. I've already talked to Michael about it, and I was fooling with my internet connection. So the Whisper Daemon that I have is still running and it's still storing all the data. So once Michael helps me get it straightened out, it should all upload and I won't have a break in data.
okay, well, that's fine. Don't uh, don't worry about it unless you start to, well, I don't think I ever put a limit on the size of the spot upload cache. So it's possible to overflow it, but you don't spot.
I have
spot
still
okay.
quite a bit of space.
Then that's not gonna,
available.
yeah.
So it as long as I don't wait a month or something.
Yeah. Yeah.
But Michael's going to help me, he said. So
Okay. Yeah, he will. I started to inflict a fire hose of information on him
yes.
about
He's pretty good at absorbing that fire hose.
I think this one was too intense. I think he looked like he was drowning under it. I have to anyway. One of the nice things is that ChatGPT is very good at helping you create documentation. Which
yes.
I'll be. And just as we speak, I've brought up my Whisper Demons server for the new one, and now I can give it to to Phil Barnard to see if he can't get his whisper.rocks talking to the new server.
Very good.
Okay, I think that's about it for me.
Okay. Well, take
Unless
care.
somebody
And
has anything else.
thank you for all that you do, keeping this
We
thing
all
running.
We all do. We all do think our part here. So, Paul, I miss Paul with Paul is working on the layout of. You're working on the.
Yeah, the new AAA or the DV8, as some of us have been calling it.
I like.
Yeah,
I like. I
it,
like the
Yeah.
DV.
Yeah, the only
it's
thing is the DV makes me think digital video, and I don't want to confuse people, but among friends, I think we can call it
I
the
think.
DV8.
Yeah.
yeah,
Yeah, I've been working with Dave, but also I got some really good information from Franco
good.
about basically the IO pin assignments, and I've been looking at the the driver code versions of the various versions of the driver code. Still have some questions, but I'll be emailing those out and, um, hopefully get some answers. Yeah,
Uh,
these things, there's so many versions of this thing and they're all a little bit different, but I'm trying to make the new one as close to the current, the AAA Mark II or whatever it's called. Um, just stripping out a lot of the cruft that we don't need, but
yeah.
trying to make everything else be in the same place as it was, in the Mark II. So the driver, there won't have to be a lot of changes, if any, to that. So I got to make sure I got all the pins mapped properly.
Mm.
Um,
I hope I got you. I gave you as much as I know and as much as I could dig up. Uh,
Yeah, no, I got that and been looking through it, and some of that I already had, but some of it
yeah,
was new. So I'm just trying to kind of cross
yeah.
reference everything, and hopefully,
I,
what sifts through the sieve will be appropriate. And
I know.
I'll run it by people before I
Yeah, yeah.
get it much further.
Yeah, don't hesitate. I would talk to Tom at some point about it too, because he's pretty aware of it. But yeah, I apologize if, I'm sending you things I've already sent you in the past, but
Uh,
it's so much easier for me at least when someone references a document or something, if it's right there in the email, as an attachment,
no apologies. No,
so you
it's
don't have to
great.
go looking for it.
Yeah, no,
Yeah,
it's good. Thank you. Tom, which Tom is this?
Tom
Right there.
McDermott.
Okay.
Yeah, because what
And
he's doing is not wildly at variance, with that four channel
Yeah.
and he has certainly seen all this, all these pieces that we're talking about, and he just knows this stuff. But so having those notes in my version of the KiCad stuff are almost all from him, and the comments he's made. And so,
and
Okay, great.
and Paul, Tom lives halfway between your two houses in in Oregon in Medford, and
So
he
he's 450 miles from anywhere then, as far as I'm concerned. But
right,
um,
and he's working on the other version of a radio, the 4 channel.
yeah, I saw his that was his board
Yes,
or the layout he was showing. Okay.
yes,
Yeah, no, that looks good. Different beast, but some
yes.
commonalities for sure.
yeah, it's mostly that's a much more difficult connector to route, that those come with. They use that high density
400 pin.
mezzanine connector that.
Yeah, no, on the board I'm just, well, again, it's a different thing, but I'm using the 121 pad BGA directly on the board, as is done with the Mark II
Yep.
to 888, and we'll we'll see how far I get. Hopefully far enough to make something useful out of
Yes.
it. And at some point, yeah, Clint, maybe talk with you and Glenn about noise floors and dynamic range and all that. You know, and going single-ended at the input to the variable gain amplifier and all that stuff. And how the hell do I interpret the noise and dynamic range, or the I forget what the spec on the ADC, you know, is an effective, you know, effective number of bits, I think ENOB or what, something like that. Uh, if we, I'll probably need some hand holding to get that figured out, but not there yet.
Bye, Rob.
So, and it's time for me to bail too. So anybody, unless anybody has something for me, I'll say goodnight. Nope. Okay.
Talk to you next week.
See you
Paul.
guys around the corner next. Well, I'll see you this what is it, Saturday?
Saturday.
Saturday. Yeah, it's on my
Yes.
calendar. So I'll be
Well,
ready
mine
for
too,
that.
so.
Okay. Talk to you guys later.
Bye.
Bye.
Bill, you still around?
Yeah, I'm here.
Hey, the other day you were talking about ionograms and picking up the sweeps, and you had some ideas on what you were going to do, and you were talking
Yeah.
about like a Doppler.
I haven't really given a lot of thought since then. I mean, there's a bunch of ways of doing it.
I'm kind of curious if you want to explain a little bit to me, if you're up for it.
Well, you know what the problem is, right?
You're chasing a frequency.
Well, yeah, I mean, you want a receiver that can, you know, continuously change its center frequency as a function of time. If you need to do that only slowly, then I already have that mechanism, because all you have to do is vary the fine frequency oscillator, you know, the one that operates in the time domain and runs between plus or minus 20 hertz. But that assumes that you don't have to flip it more than 40 hertz per bin. And even then, it would depend on the phasing of the, you know, when it crosses the boundaries between bins. So solving this in the general case is going to take more work, because the down converter is not set up for this. There must be a simple way to do this, simple and elegant way. I just haven't thought of it yet.
So if you did have the ability to skip bins and, you know, do the frequency in sync with the transmission, there'd be a time offset, which
Right.
would be a frequency offset.
Right.
So as you sweep the receiver and the transmitter, would that frequency offset be consistent?
Well, if the time offset is. I'm not sure what you mean. I mean, assuming that I'm sweeping at the same rate as the transmitter, then
Right.
the time and frequency offset would be proportional to the delay.
So then when you demodulate it, you would be looking at, say, an IQ signal with a constant offset of maybe a kilohertz or a few hundred hertz, depending on the
Well,
time
if
offset.
the signal is not being, there's no multipath in this signal, there's no dispersion, what
Okay,
will come
yes.
out will be a constant tone. And the frequency of that tone will depend on the distance and the relative phasing of the sweep between the two ends. If there's multipath components, then what will come out would be a combination of several tones at different frequencies, each one according to the the relative delay. Right?
Yeah, I can see where the delay definitely would change the tone frequency.
Right.
And I can see if
That's the
you're
whole reason for changing the tone frequency.
Yeah, and I can see where if you know the sweep rate and you're synchronized to the same sweep rate, then that frequency is approximately constant.
Yeah, as long as the delay is constant.
Yes.
It's an old method. I mean, it's been done since at least the late 60s, if not earlier. But the implementation's changed a lot. I mean, you think of it as a modification of a Doppler radar. The Doppler radars are great for velocity, but not for range because all of the range components land on top of each other. And when the velocity is zero, it lands on top of the transmitter.
Hey Phil, Rob was discussing a problem that there's occurring at K3LR. That did you hear him mention that?
No, I came in about a half hour late. I was out working on my car.
Right, right. Well, what he talked about was that K3LR sometimes is used for transmitting. So it's
Sometimes.
yeah. So the radio gets desensed. I'm just wondering if it would make any sense whatsoever. Well, and Rob pointed out that if you back it off to where it's not being overloaded, you can still get quite a few signals. Your noise floor has gone
Yeah.
down. I'm just wondering if there would be if it would make sense to have perhaps in, this is feature creep, something that would kind of lock out the AGC after a strong signal for some number of seconds. Like suddenly if you're presented with like a negative 20 dBm signal, to kind of hold the AGC there for, that would persist it at all, hold it there for like 5 minutes or something like that, so that it's not constantly relaxing and getting smashed and then losing.
Well, that means you won't hear anything during that time. I mean, why? I mean, I'm not
Well,
sure why.
well, what Rob is apparently doing, or was thinking of doing, is manually disabling the AGC and setting it so that it's not overloaded.
Well, you can certainly do that, but
Well,
then you're throwing away a lot of dynamic range when there is no signal. There's no transmitter
right,
signal.
right. You probably need to find out from Rob what the bigger problem is, but the AGC on K9Q radio is relatively slow, I think, to react in either way.
Well, the reason it's slow is because I want to avoid the artifacts of changing gain. If there's no changing gain artifacts, then I would want to be fast.
Right. Yeah. 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 I know what you mean.
And the RX AAA seems to have fewer artifacts than some of the other front ends I've tried, where there's a very noticeable glitch every time I change gain.
Right. Yeah. Yeah.
I mean, I've improved it quite a bit as a result of experience at DP0 GVN, because whoever's down there has been running a lot of FT8 on 80 and 160. And calling CQ for 15 minutes at a time, which means 15 seconds on, 15 seconds off.
Right.
And my noise averaging algorithm was not responding quickly enough. It wasn't just the AGC, it's the broadband noise being emitted by the transmitter near the frequencies it is sending because of phase noise, phase noise from the local oscillators. So I revamped it quite a bit so that it now averages more over frequency than over time. But it still does some averaging over time. It's just much faster. It's on the order of a few hundred milliseconds.
Oh, okay.
So that should respond very quickly. Now I am interested in more, comments on that and how good the N0 estimator is when the input signal levels are changing rapidly. And I should say the noise levels are changing rapidly. Other than that, I mean, there's no way you're going to be able to hear while the transmitter's on, and at any ratio greater than the instantaneous dynamic range of the A to D converter.
Right. What I was thinking of more is the recovery period after when they unkey, and then yeah, the recovery period when they unkey, how quick.
Well, that actually ought to be, when you think about it, should be very fast, right? Because if the signal's gone away, you're essentially deaf. There's no harm in causing an artifact, even if there is one, in order to get some signal again.
Right.
I just don't want to make a lot of little changes, gratuitous changes, introduce a glitch each time. So I'd rather, if I'm going to make a change, I want it to be a big one and make it worthwhile,
Right.
but
Yeah.
not wait to do it if it's really needed.
Well, what I was wondering though is if there's a strategy that could be implemented that where you will accept the trade-off if you have a frequent presence, maybe a monster signal to allow quicker recovery. But it sounds like you've revamped the AGC since I last looked at it.
Yeah.
Recovers rather quickly, rather than like looking at your watch and waiting for the 30 dB of gain to come back, taking tens of seconds.
Yeah. Well, remember, this is all separate from the AGC and the channel, but I assume you are
Right.
talking about the front end.
Yeah, I'm not worried about the in-channel one because that's
Yeah.
and
I mean, the only time that the AGC and the front end should be needed is if the signal is stronger than the instantaneous dynamic range down to noise. And if that's the case and it engages, then you were necessarily sacrificing some sensitivity down at the low end. You have to.
Right. Yeah.
And so when the signal goes away, I want to get that back as soon as I can.
Okay, so I know originally when you implemented front-end AGC, it might take tens of seconds for 30 or 40 dB to come back.
Yeah, I did that mainly because other front ends had much worse artifacts in the
Right.
electric plate. I mean, this can all be tuned. I mean, I'm looking, I certainly would like to have some empirical observations on how fast this stuff should be, how
So
much hysteresis there should be.
so how fast does it come back now? Supposing
Let me see.
supposing you're recovering 40 dB of front end, whatever.
I haven't looked at it in a while. Let me see what it is.
Well, 40 dB is probably excessive because that's probably as much as you have anyway. But
You say 40?
Well, 40 dB is about as much. Well, unless you're using the actual attenuator on the receiver, which.
Sorry, wait a minute. Did you say 4 or 40?
40.
40. Okay.
Well, yeah, I'm just trying to think of if you have a. See, I think the gain of the VGA is from like plus 34 to minus
something.
Yeah, more than minus 10.
Yeah. All right. I am trying to keep the AGC digital output between minus 15 and minus 26 dBFS.
Okay.
And I run the loop every 1 second.
So you do an estimation on before? I think you just adjusted it in steps. But
yeah, I look at total power, and I'm trying to keep that total power within that range.
Okay, but yeah, I think before though you did steps, and then you and now do you? I mean, just like didn't you just? So how did you when you were recovering the gain, which is the trickier problem because you can't know ahead of time what signal is going to blast your A to D converter, and all you can.
Well, it could happen at any time, and
right.
I just have to respond reasonably quickly to that. Let's see.
Well, like the classic example that is summertime static.
Yeah.
You don't want to recover too quickly because then you're going to be clobbering yourself.
Well, wait a minute. If summertime static, I'm not sure I should do anything. I should just ride through it.
Well, yes and no. I mean, but I mean, I know what you mean. But
yeah. I mean, if it's impulsive, then let the impulses clip.
Right. Actually, I'm thinking more of what we have to do on the Utah SDR front end, but those are band specific rather than those are band specific A to Ds rather than everything. And you would treat those differently because you can kind of count on. I mean, in a specific amateur band, your noise floor is going to be high relatively anyway. So,
right.
Yeah, so you treat it differently than like summertime static on a wideband receiver where the noise at 3 megahertz may be horrendous, but at 21 megahertz it may be non-existent. So you don't want to clobber your 15-meter gain in favor.
Well, yeah, that's an advantage of using a narrowband SDR if you have a lot of them.
Yeah,
What
yeah,
you do in one band can be different what you do in another band. If it's a broadband SDR, then you got to do the same thing for all of them, unless you're going to have some analog filters in front.
right.
All right. One thing I could do is currently my AGC, front-end AGC runs synchronously at a 1 hertz rate. I could make it asynchronous. I could trigger it whenever the power goes above or below some threshold. I could
Right.
do that.
Yeah, I mean, in the case of in the case of like writing summertime static, I was thinking more of the trade-off between, well, let's see here, I guess, yeah, considering the rise time of summer static, I mean, there's sort of a haystack in energy because it's spread out, and there might be some more optimal thing where you might reduce the gain a little bit so that the disruption where you're totally smashing your AGC or ADC is shorter duration at the expense of losing a bit of sensitivity, because if you clip it, you ruin everything on all frequencies, obviously.
Well, but if it's a strong impulse, there's nothing I can do about it.
Right. But the thing is, if it's what is the trade-off between, you can reduce the gain somewhat to kind of only to to be completely desensed during less of the peak, only the top upper part, and
Well, I actually don't know what broadband lightning looks like. If somebody can show me
yeah,
what broadband waveforms of lightning look like, I
yeah, I
could.
guess that's a good point. But kind of what I'm saying. I mean, there might be some strategy where you reduce the gain somewhat, so you don't take too much of a hit, but you reduce the time at which you get deafened by the higher pulses. The duration of the deaf period.
Okay.
Yeah, I mean, but yeah, I mean, yeah, but
Well, unless the impulses go beyond the range of the converter, there's no need to do anything.
right, absolutely.
And if they do go beyond, I mean, unless it goes far beyond, there's nothing I can, if it goes far beyond, there's nothing I can really do because I basically turn the receiver off anyway.
I mean, there's a reason, of course, why you're trying to shoot for a target of what, negative 20 dB FS, something like that.
Between what did I say, minus 15 and minus 26, I think.
Yeah, I mean, that in itself implies a strategy. I mean, if you knew what was going to happen before it happened.
Yeah. Well, that's kind of implicitly assumes that the input is Gaussian
Right,
and it's near stationary,
right,
meaning that the standard deviation doesn't change very much, which is true for diurnal galactic noise.
right,
And it's true for all distant signals. The only time it's not true is for strong local signals. That's the only time it can be non-Gaussian, because in order to be non-Gaussian, you have to have just one or a very small number of them,
right,
strong signals. Otherwise, from the law of large numbers, no matter what it is, it's going to sum up to Gaussian,
right. Yeah,
right? It's law of large numbers. And it doesn't take very many before you do get almost Gaussian. Law of large numbers kicks in for actually fairly small numbers. So the only time it's not going to be Gaussian is when you have a very strong local source. And that's going to be nearby lightning or a nearby transmitter.
for some reason, I got it. I was thinking, I, for some reason, while you were talking, I was thinking of, it would be nice if you could get a glass delay line that would delay the front end by signal by a reasonable amount of time, so you could. Well, I don't know. I mean, in theory.
Why don't you just design me a wider range A to D converter?
Well, yeah,
what I'm really trying to do here.
Yeah, I did look it up one time on DigiKey, and I think the biggest, well, not DigiKey necessarily. I think the highest number of bits that was in any way or shape affordable was like 20 bits for for.
I think that's kind of a point. Even 16 bits is kind of too much on HF because you're never going to get that kind of dynamic range off the air at any given instant. Certainly not in a narrow frequency range. I
Well,
mean,
not in
any
a narrow
individual, yeah.
but
And
I
if you
mean,
flatten the spectrum with a shelving filter, you make its job a lot easier.
well, yeah, except of course, like right now, when the shelving filter when the bands are open, the shelving filter becomes irrelevant when the high bands are open. Yeah, irrelevant to a degree. You know what I mean?
I'm not sure what you mean.
Well, I mean, one of the ideas of the shelving filter, of course, is that most of the time, the lower frequencies have stronger signals than the higher frequencies. But when the bands are open, you get some whacking strong, like especially in Europe, you get some huge strong signals. Although, up on the higher bands.
By higher bands, do you mean about 15 megahertz?
Yes.
Okay.
Like the guy in the guy that's in has the EA3 one, the one in not where all the telescopes are.
Madrid.
No. Canary Islands.
Oh, all right.
In Canary Islands, he was talking about. He came on to Rob's call one time and was talking about how he was often seeing multiple transmitters out of Europe that were like minus 15 dBm, minus 20 dBm.
On those bands?
On higher bands, yes, 15 meg and
Higher
higher.
bands. Maybe what we need is some kind of adaptive analog filter in front of all this. A
Yeah,
tunable roving notch or band pass or band notch or something like that can
right.
knock out some of these.
I talked to Paul about it, and the only thing that comes to mind that would be that would work, that would be, well, one of the few things that came to mind was like you know the synchronous detect what is it? It's so-called the Talo.
Yeah. I know it.
You can turn that inside out and turn it into a notch if you want. You can just
Okay.
right. Other than that, and you could make the notch. You could make the notch. It only needs to be like 20-25 dB deep to be useful. I mean that's
Yeah.
but uh, but but that's the only thing I could think of where you could have a notch using relatively simple components, as in multiplexers and even RC filters on
Yeah.
the quadrature side that would be in tens, maybe tens or 100 kilohertz wide, which would be perfectly adequate for band adjacent transmitters. What other means could you imagine that would produce something that sharp that'd be electronically tunable?
Yeah.
I don't know. I mean,
Well, sharp, I mean, notches are sharp, but they may be too sharp. I mean, is there only one offending transmitter or more than one?
oh, there can be multiple offending transmitters in Europe.
So you need a band stop rather than a notch.
True.
That's more work.
Right. The other thing too would be there's a ham John Leonardo that he and a bunch of other people got some custom quartz crystals made and had 2-pole quartz filters for every whisper frequency.
Oh, well, that's really,
I mean, that's one way to do it.
that's dedicated. Yeah.
Yeah, I mean, it was hundreds of pounds for these things, but they were extremely effective. I mean, they didn't.
Oh, yeah, it should be.
Yeah, I mean, they were crap as far as filters go, but I mean, but they did
Yeah.
the job.
Well, I mean, it's a similar problem here trying to monitor the VHF airband with strong FM broadcast stations nearby. I've simply notched out the FM broadcast band. I got version 2 of the what is it filter
One of the new elect ones.
Newelec, yeah,
Okay, yeah.
and it works very well. In fact, it works so well I can't even hear I can't demodulate the FM broadcast stations. They went from overwhelming to no, not detectable.
Oh, okay.
But it means that if I ever want to get those bands, I'm just going to have to put up another antenna and another feed line.
Well, yeah, either that or tweak the filter a bit. It's a due task.
Well, I can't really do that. I mean, the signals are so strong. I find that, well, the filter, right now precedes a broadband preamp and then a four-way flat power splitter. And I found that if I swap the order to the preamp and the filter, my signal noise ratios on the ham bands went down like about 15 dB. So even one stage of amplification is too much
Right.
for those FM broadcast stations because they're so strong.
Oh, okay. They're that close.
I put them on a spectrum analyzer, my antenna on a spectrum analyzer. I forget how strong they were, but they were way up there.
Right. Yeah.
I mean, I can see the tower lights, so
Yeah. Yeah. Okay.
and it's not just one; it's at least a dozen.
What receiver was that? That like the RTL, or is that something better?
The receiver is well, AirSpice and a Hydra, but I'm listing on ham bands,
Okay.
and I think they have. I mean, it has a tuner that actually isn't all that bad at rejecting the rejecting out of band signals. The problem is the amplifier was getting swamped. The amplifier is a broadband amplifier feeding a flat four-way power splitter going to four of the RTL SDRs. So I can listen to four bands at the same time.
Okay.
And I did the experiment, filter first, amplifier first. What this means is it's going to be difficult for me to put a preamp up at the antenna because I'm going to have to put a filter ahead of it.
What sort of preamp are you trying?
Oh, it was one of those, another one, UP-Tronics amplifiers. I bought it several years ago. It's a broadband preamp that runs from, I don't know, a little 100 megahertz up to a couple of gigahertz, something like that.
Oh, okay.
I think there's only so many different ones. I mean, they all generally use the same monolithic broadband preamps. And
Well,
so,
I'm just wondering if one of the favorite preamps in those things like the Galley 70 something, whatever, which have very low noise figure, 2.5, 3 dB, but they have like 22 dB gain, which is way too much in my opinion.
probably too much, yeah.
Right, right. So a friend of mine, another ham, he was having the same trouble, but I suggested he use the now ancient MAV11, which is only like 10 dB gain, but it can handle, but it's but it's P1 dB is like plus 20 dBm, and it has about a 3.5 dB noise figure.
Yeah,
That actually
that's
saw.
not bad. Well, the main reason I needed some
Yeah.
gain there was to overcome the loss in the splitter,
Yes.
which for four-way would be what, about theoretically 6 dB. It's probably in reality more like 7 or 8.
One of the other things too, I don't know how much you are into homebrewing, but the other one is, and I've built several copies of it and been very pleased, is the Norton noiseless feedback amplifier. I don't know if you've run across that.
No.
That one's freaky. It only pulls a few tens of mils, but it has insane dynamic range. Let's see.
I thought dynamic range usually required a lot of power in receivers.
This one this one is a very tight feedback, but amplifier. But it was popularized by W1JR Joe Reisert in the 80s.
Yeah.
Still under patent back then, but it's obviously no longer patent now. It's a W1JR Norton preamplifier. Let's see here, but that one. Let's see. I'm just trying to find it here. But that one. Let's see. Crap. I'm trying to find a good example of it.
All right.
Let's see here. Norton noiseless feedback amplifier. Better put RF in there as my search term. Let's see here. Okay, KE5FX. Okay, he talks about those. You know that. Let's see here. I'm just. Let's see here. He uses it as a distribution amplifier, a low noise distribution amplifier for cesium clocks. And
Okay.
that's probably, let's see, that's not exactly what I wanted. I built them using, usually I build them using the 2N5109, which unfortunately is getting harder to find. But that's the, let's say, bulletproof, extremely linear transistor, but there's some decent ones.
Well, what's wrong with these monolithic amps?
Well, usually they have too much gain. That's the problem.
Yeah.
Right. But the let's see here. But I think the Norton one would actually run circles around it. In terms of IMD performance, which I guess is kind of important.
Yeah, well, yeah, if I'm going to allow FM broadcast, maybe, like I said, the simple fix was simply to get rid of the FM broadcast band. Problem solved.
Yeah, I'm just looking here. Common base. Oh, here's one article, I think. That's not the one I'm thinking of. Okay, well, this is an article that's worth looking at least, if nothing else. Let me throw it in there. I think that did it. There it is. And some people go insane and put them in push pull to reduce the even order intermod products even more.
Right.
But yeah, it's a bit of a pain in the ass amplifier to build, just because, but they do, and you'd probably be. I don't know that most people use them in at VHF frequencies, but they ought to be scalable there. Just looking here, Rhodian Shorts, I guess, uses a version of that in some of their stuff. So, and apparently there's an article that Dr. Rhodey talked about it, but anyway, it's probably overkill, but that is one of the problems I've run across, is that it's hard to find a moderate gain amplifier, because people just want gain. People think that,
Well, yeah.
yeah, obviously.
Well, yeah, I'd like to have gain to, lower the noise figure in my system, and not if I'm going to have huge amounts of intermod, it just defeats the purpose.
Right. Yeah, one of the reasons I built one of these Norton amplifiers that's at KFS, and it was mainly because we needed to maintain it was exactly the purpose for which you refer, where we needed to maintain the noise figure to a degree prior to any filtering or splitting, but we didn't want it to get clobbered by strong signals. And in fact, we were getting them. We were, for a while, for a couple of years, we're using one of those qubit amplifiers. The problem is they have like 24 dB a gain, and although their P1 dB is north of plus 20 dBm, they were still being overloaded in the local mornings, when the combination of all the Asian foreign broadcasters is just blasting over the sea, was just murdering the front end of KFS on the Omni distribution side. And apparently that hasn't been an issue since this was put in.
I just looked up Norton amplifier, and Wikipedia says it's also known as a current differencing amplifier.
Probably.
Is that the one? 2 low impedance current inputs and 1 low impedance voltage output. Output voltage is proportional to the difference between the 2 input currents.
Yeah, I mean, yeah, the amplifiers I'm talking about are typically common base, so they kind of fit in your description.
Okay, they say commercial examples, the LM3900.
Well, that's a different thing, but yeah, I know what you mean.
And the high-speed LM359, which has a 400 megahertz gain bandwidth product. Introduced in the mid-1970s, so it's not new.
No, Dr. Pease loved writing about Norton amplifiers. Yeah, so David E. Norton, I guess, I don't know if it's the same Norton as the
Might
39.
not be. Norton's not an uncommon name.
Right.
I do not. I'm looking at the bibliography here.
Yeah.
I do not see
Don't know if
Norton
it's
per se.
don't know if it's the same Norton. That might be let's see here, the yeah, the IP3 on one of these is the IP2 is about more than plus 40 dBm, and the IP3 is more than well over plus 30. And
Right.
and they only pull about 60 milliamps, the versions that I built. You know,
Can't you, one way to get better dynamic range is to run higher voltage?
I suppose that's true, yeah. I mean, within reason. I mean,
It burns power, but
that's the traditional, and like those Motorola cable TV amplifiers and everything always ran on like 24 or 28 volts.
yeah.
Yeah. But that's also an example of too much gain. Like there's the guy in Australia, the VK5, who has the remote receive site an hour from anywhere. He uses one of those Motorola amplifier modules, and it has just too much gain. I mean, when the Chinese SWBC are blasting into Australia, the RX 888's running at like gain is running like -6, -8.
Yeah.
And then when the band is dead, the thing is running like at 22 dB gain or something like that. So he
Yeah,
has,
that does seem like a lot.
but he actually is apparently overloading that amplifier, that Motorola amplifier.
Yeah.
And it's good for like 100, 200 milliwatts.
You mean the ones used for
Cable TV.
repeating out in the cable TV plant?
Yes.
Yeah, they run at pretty high signal levels. The pads that feed each house are usually around 25, 30 dB.
Right.
And they deliver nominal signal level they deliver is 0 dBmV.
Right.
I don't remember how many milliwatts that is, but that's 0 dB to a reference to 1 millivolt. So it must mean the signals in the cables are running at, plus 30 dBmV.
Yeah,
Wait a minute, 30 dBmV would be no, not a volt. No, because never mind. It would be that would be 60 dBmV would be a volt, wouldn't it?
yeah.
Yeah. So, 30 millivolts or so.
I can't seem to find the amplifier he was using in my search, but yeah. But yeah, I got the idea of excess gain got drilled into me early on when I was doing radio stuff, and then
Yeah.
in the satellite industry also. One of the last things you want is more gain than you absolutely need, especially if you have problems with terrestrial interference in a radio.
Right.
Yeah.
Well, here I need some gain. I need to overcome the loss in my splitter.
Right.
And eventually I want to overcome the loss in my feed line. Right now, I don't have anything up at the antenna because if I did put something there, not only would it have to be weatherproof and supplied powered by a bias tee, but I'll need a filter in front of it.
Right.
If it's going to be as, sensitive as the filter is, the amplifier I'm using down here. This is on my disc cone that I'm using to monitor basically all of
okay.
Everything that a disc cone can get.
Right. And you use that for low band through UHF, I take it?
Well, the disc cone I used for monitoring, mostly for monitoring FM repeaters.
Oh, okay.
On three bands, but I also use it for VHF airband.
Okay, yeah. Yeah, those are the old Radio Shack ones, probably.
It's Comet, Diamond, one of those.
Okay. The Radio Shack ones actually had a stinger on them that it would work on low band only
Well,
because
so does the Comet Diamonds. They have a stinger on top.
probably made by the same people then.
Yeah, it just turns it. It's just a whip. It's supposed to take it down to 6 meters or so.
Yeah. Okay. Yeah. 'Cause
I mean,
know
I certainly hear the California Highway Patrol just fine on 40 megahertz.
right.
30.
Yeah. Okay. Well. Yeah. Yeah. Here we have at the SDR we had the problem of at least 3 kilowatt stations coming across the Great Salt Lake, 50 kilowatts during the daytime, and only one of them is 50 kilowatts at night.
Oh, AM.
Yeah, AM. And so
Yeah.
during the daytime, when there's no special propagation, we're getting like minus 15 dBm off the TCI 530.
Yeah.
Most of that is AM broadcast, and most of that is the 350 kilowatt station. So the filter that's in there actually would knock things down by 50 dB, but there's a bypass in there. I just did the cheesy thing and put a bypass pot so that it brings the noise floor, brings it so that you hear the weaker stations. But when I did that, I still had to put in. I have 6 notches tuned to the various stations. There's a few 10 kilowatters, 5 kilowatters that are much closer geographically that need to be knocked down. And the result is we're able to put all the AM broadcast band into an RTL SDR plus 160 and not have it overload. But it's a little deaf, but at night you can hear everything. Things every 10 kilohertz. You know, at night there's no problem. In the daytime, it's a little bit on the deaf side compared to the key.
I'm beginning to think maybe broadband's not such a good idea anymore.
Yeah, I know what you mean.
You know, maybe you have 2 for HF, one for the low half, one for the upper half, because they're like 2 different problems, really.
Yeah, 2 or even 3 of them, but yeah. I know what you mean. Yeah. Yeah. The other thing too is I suppose it should be possible to just have. I mean, this would be something to talk to Paul about, but if you could have a well characterized and repeatable, adjustable, filters that could bring up and down for the various segmented filters for the essentially shelving filters that you could adjust up and down.
Well, that would be ideal, but it sounds expensive, a lot of discrete components.
Right. Yeah, I know what you mean.
I mean, this is why the older SDRs narrower SDRs are somewhat expensive because of all the pre-selection that goes on. That's something you can't easily integrate.
Although the pre-selection for the your favorite one, the RSP, isn't all that great. I don't know. I've never actually got my hands on the AirSpies to know how fundamentally different they are.
I don't know either. They have an they have a TV tuner in the front end. I don't know if there's any additional filtering ahead of that.
Well, yeah, the AirSpies, of course, I'm not the AirSpies. The RSPs do use the TV tuner chip, but they have the biggest downfall is they have one filter that covers 2 to 12 megahertz.
Yeah. And
the problem is they essentially use something akin to a QSD for the down conversion to baseband, and that has a odd order response of about negative 26 dB, which means if you tune in 80 meters in the daytime, you will hear only 3 S units down the 11 megahertz shortwave broadcast stuff blasting through. Only 26 dB down.
See, San Diego, Mount Soledad, 9 FM broadcast stations currently listed there. Each one of them, I think, is running about 20 kilowatts EIRP.
I live only about I don't know, about 6 to 8 miles from where all the transmitters are, but most of them are shooting above my head because they don't have a lot of down tilt because they're most of the I mean it's the near far problem. There's no point in sending all your power to the people that live right really close to you because they're going to be strong anyway. So fortunately, it doesn't have. I'm below the bottom of the down tilt for the most
Well,
part.
I'm far enough away, and the shape of the terrain is such that I'm probably right in the middle of their beams.
Oh, okay.
Curiously, they're omnidirectional, even though it's that tower is almost right on the ocean and is throwing a lot of their power over the Pacific.
I don't know why they would do that other than maybe
Yeah, I don't know either.
too expensive to do otherwise. Yeah.
Yeah.
Here also, well, at least I don't know too much about the pattern of the FM broadcast, but I know for the UHF television, they kind of have sort of a dumbbell pattern that
Yeah.
you've been to Salt Lake area. Salt Lake, a lot of the population's 40 miles north and south of Salt Lake.
Yeah.
Years ago, we put up an analog ATV repeater, and it turned out that when I ran the numbers, the the communities that were 40 miles north and south were only about 6 dB farther away ish than 6-8 dB further away. So essentially, we split the power 3 ways and used big beams for the north and south and a much lower gain wide beam for the stuff that was close. And when it all is said and done, the signal level is about the same, over the range. And but it kind of surprises me they would send stuff out to the ocean.
Well, I mean, there are boats out there, but still.
Yeah.
Okay, let's see. Now I ask, hey, now tell me, I'm asking ChatGPT to give me everything. Okay, besides the 11 full power FM stations, there are 3 licensed auxiliary transmitters, an FM translator, and then 2 TV transmitters.
Oh.
So yeah.
Do you have anything other than UHF TV, or do you actually
Yeah,
have?
no, the TV, actually those 2 TV transmitters are both VHF 8 and 10. There's
Oh,
another site, San Miguel, where the NBC is on channel 39,
okay.
I think, or actually I'm not sure what RF channel they're on. And KPBS is on physical channel 15.
Well, at least television is horizontally polarized.
Yeah,
UHF at least is. I
right.
don't know about high band VHF.
I'm not sure either.
I know the low band VHF that we had here was all both polarizations. I don't think it was CP. I think they just I think they radiated both, and there was some
Yeah.
between the two.
When I was active in broadcasting in the 70s, it seemed to be a mixture of either diagonal polarization or CP.
Right.
I mean, the only difference was, the 90-degree phase shift between the
Right.
vertical and horizontal elements.
Yeah, the bat wings are, of course, what everybody used on the low band VHF, and so those
There's very little of that now.
yeah, around
There
here
used to be the prime frequencies. Now nobody seems to want low band VHF.
there was a soon after conversion, there's one of the low power stations that was on that actually went to like channel 10 VHF when everybody else was UHF, and I guess they realized their mistake, so they were like simulcasting on both VHF and UHF for a couple of years. But last year I noticed I was tuning around on my Kiwi clone, which goes up to which goes up to 60 megahertz. And one day I turned it on, looked at the waterfall, and saw that there was a whacking strong signal at 54 and up. So I scanned the TV, and discovered a Bible beater inhabiting channel 2. But it wasn't. But a few weeks later, it wasn't there. and I have no idea what that was about.
Sure, it wasn't a band opening.
I don't think it was. It didn't seem to be fading in.
Band openings have, happen do happen on low band VHF,
They do, yeah. It
just
didn't.
like they do in 6 meters.
Yeah, it didn't seem to be fading in and out. It wasn't a very good signal on my TV. But
You never identified it?
never did.
It might have been DX.
It could have been, but when I've seen it before, this you see it undulating and you see multipath ripple through the through the spectrum. I didn't see any of that on that, so it could have been an opening, but just a really solid one. So, but yeah. One of the things about low band TV that I do miss is using it for detecting 6-meter openings. But
Yeah.
one of the other things too I noticed was for a while I lived in central Pennsylvania near State College, and we had no off-air TV channels of any kind. I mean, even
Yeah, that was true in Ithaca, New York also.
right. Even though Penn State had a channel 3, where we were, we couldn't pick it up because the mountain
Yeah.
was away. So not even UHF, there were no translators. So if you wanted to watch TV, you had to have cable.
Well, that's where cable started, was in places like that.
Well, in fact, Penn State College, Pennsylvania had at least had at one point a cable TV museum.
Hmm.
I never went to it. I probably should have, but just to nerd out. But one of the things, but there I could tune in, 55 250 to listen to the visual 55 250 and listen to the visual carrier.
Right.
Oh, no, was it no 55 750? I think.
No, it would be 55.25 would be the or the visual carrier.
And you could
or 0.24 or 0.26, but
yeah,
right.
yeah. So I could tune around and I could hear, I could hear the video carrier for KDKA out of Philadelphia pretty well. One
That's
thing
Pittsburgh. KDKA is Pittsburgh.
Pittsburgh, right. But one of the things I noticed was I would listen there. I just turn down the gain on my receiver. But I noticed I would often start hearing ping, and it wasn't meter scatter because I know what that sounds like because there's no Doppler shift on it. What I finally realized was that if there was a thunderstorm in the area, in the general, apparently the ionization channel improved propagation enough that I could hear ping of the.
I guess it would be a good reflector.
Yeah, I mean, yeah.
It's kind of like a meteor trail when you think about it. It's just lower down.
Yeah. And it'd be interesting to have looked into that more, because nowadays, of course, you could Blitzer tongue or something like that. You would know where the lightning was, but I correlated because go down to like low band HF and you hear a static crash the same instant you hear the ping, that sort of.
Then for sure.
And
yeah.
Yes, but I thought that was really kind of cool, and not all the carriers would do it. Of course, because I guess it would depend on probably the lightning had to be somewhere kind of in mid path ish, I guess.
Yeah, that makes sense.
Yeah. But anyway. Oh well.
My first encounter with cable TV was during college. I mean, it wasn't anywhere else. It was a small town with no local TV. So, we had it at Cornell before, had in Baltimore, any other major city.
I lived in rural Indiana for the first 10 years, and I remember when they put in the cable TV system in that town, and the problem there was that our DMA was Fort Wayne, and that had UHF only from the get-go. And you could only receive the signals from Fort Wayne if you put up a pretty big UHF antenna and put it up very high. It didn't have any trees in the way.
Yeah.
And there was absolutely nothing other than Bowling Green and Muntz, Indiana, different directions, which are PBS stations. But we could kind of see. I remember my dad had a big antenna up to receive the Ann Arbor classical station, which was the highest ERP FM broadcast station in the country at the time. Maybe still is. And they also had a really tall tower. And but I remember him hooking a TV up to it, and we could kind of get almost watchable stuff out of South Bend or in Chicago or Dayton at times. But the other thing I do remember too is on spring mornings I discovered this. I could tune around the UHF, on those cheapo, on those blonde or tunnel diode converters that used to be out there.
Yeah.
And I would often on like weekend mornings, during the spring, I'd tune around and I'd get UHF stations from all over the place, from West Virginia and even Missouri and stuff like that.
Oh, I remember when I moved to Chicago after school, I was amazed by the summer tropo openings.
Oh yeah, I mean, and we're talking, like channels in the 30s to 50s, and that's that's like 600 meg.
Oh,
And
that high. I remember the 2 meter openings, you'd hear repeaters in Alabama for hours
oh yeah,
in Illinois near Chicago.
yeah, yeah. Occasionally we get that here, but I don't watch it that often. But I have heard generally what we hear is what I've heard most often is in the morning ish we'll get single hop out of maybe Texas and Louisiana on 2 meters,
Yeah.
and in the evening I guess it kind of parallels 6 meters. I guess in the evening we're more likely to get like Northern California and the Pacific Northwest. I mean, but it sort of
Yeah.
swings around. And when I lived in Pennsylvania, I ran a lot of 6 meters. And that's the thing I noticed is like to the east in the morning and it'd swing up to the northwest and by the late afternoon. Oh, that was usually what it did. And here it's the sort of the same thing.
Was this tropo or e-skip?
That was e-skip. But the stuff for the UHF TV stations would have had to have been some sort of tropo of some kind.
I guess.
Yeah, I mean, I don't know what else it would be. I mean, the signals when they were in were rock solid, and I
Yeah.
remember seeing IDs. But I remember seeing them out of New Jersey and West Virginia. Yeah, definitely. And, and of course, the ones out of South Bend would occasionally just blast in. There were normally 2 week. We had some of them. There were some of them on UHF, and
Yeah.
normally they were just kind of there. You could kind of get sync bars occasionally, but sometimes they were just blasting in just for an hour or two or something. But anyway,
I remember when I was in early in my satellite phase, and I was building 70 centimeter helices and so forth. I found that they were remarkably good for low end UHF TV DXing in the summer.
Oh,
in the Chicago area.
Oh, yeah, good old analog days.
Yeah.
But then the analog days is a really diehard TV DXer guy, and I wrote an article before. This is pre-blog where I had experimentally built an IF TV IF filter that was only 300 kilohertz wide. And through that, of course, you get a blurry black and white picture, but you get a blurry black and white picture at 10, 15 dB below where you can get anything with a standard 6 meg.
Well, why not go, if you're trying to identify the station, just go after the audio.
Right. Yeah. So I built it for him, and he actually did use it. I think he used the ICOM R7000, which
that would work.
Well, and that had a TV module, DMOD module that went.
Yeah.
But
I had an R7000, but I never got the TV module.
Right, but the IF of the TV module was really low. It wasn't 45 meg. It was like the center of it was like 11, 12 meg maybe. I mean,
it wasn't 70 or something like that.
Oh no, it was
okay.
HF,
I
And
guess you're right. I never got the module, so
yeah, I'm just like
and that
RS7,
receiver is obsolete to me now.
right? Well,
I
yeah,
gave mine away. I had one for a long time and I gave
I
it
have one
away.
on the shelf here that I inherited from a deceased ham, but yeah, but I mean, let's see here. Oh, there it is. I found my article. I'm just looking here to see what frequency it is. Oh yeah, it is. Oh, it's a 10.7 meg IF.
Okay.
Yeah. So the video the video carries at 15.2 meg. So I built him a box that I think it had 2 or 3 settings on it that would be, besides bypass, that like
Yeah.
1 meg and then 300 kilohertz. But
Enough to get sync in a blurry black and white image.
well, actually, let's see here. In fact, I actually generated a signal and let's see, and there it is. Yeah.
Oh, cool.
There it is.
That's it.
Through the 300 kilohertz.
Yeah, it's
Yeah, I mean it looks like crap, but yeah. Anyway,
it also has its vertical resolution.
that is true. That is absolutely true. Yeah.
Every time I see that arch, I think of a Roadrunner cartoon.
Oh yes.
Every time I see a Utah license plate, I think of the Roadrunner cartoon.
I have that arch on the license plate on my Jeep. So yeah. I mean, yeah. And
I always thought Wile E. Coyote should be the engineer's patron saint.
yeah. I'm driving through parts of Utah, and I think the Roadrunner cartoons could have been filmed here.
Exactly.
In fact, I think there's a Hollywood movie that's supposed to be coming out eventually, like Roadrunner versus Acme. It hasn't been released. It was made years ago, but it was one of those where Warner Brothers decided they could make more money by claiming a loss on it than releasing it.
Oh man.
So, and I did hear where some production company had negotiated it to be released, but it still hasn't been done yet, from what I can gather. But yeah,
I love those cartoons. I still do.
yeah. They made like a half a dozen of them in the past decade or so.
Yeah.
You can find them on
Yeah, they do. They occasionally, but well, the original Roadrunner cartoon was supposed to be a one-off. It was supposed to be a parody of the Tom and Jerry
oh
type
yes.
cartoons, and then it was so popular that it just became a series in its own.
So I've spent a lot of time in backpacking and also driving around in some of these areas. And one time we were actually a part of Canyonlands National Park, and this Dutch couple, I think Dutch or German couple, approached me and with holding a map and said, "Excuse me, we are going to Texas." Okay, that's good. Where in Texas? Fort Worth. Oh, what do you need to be there tonight?
Oh boy.
The person I was with, I looked at him and they could apparently we looked shocked, and I said, no, why? And I said, I just pulled something out of my ass, which turned out to be correct. Driving from here to Dallas, Fort Worth is like driving from Amsterdam to Milan. And then they looked horrified.
Yeah.
They hadn't gotten the scale of it, which
yeah, it's amazing how many Europeans do not understand the scale of the United States.
Right. That's a 22-hour drive.
Probably.
2-hour drive. I know it because I've driven to Dallas Fort Worth from Utah.
Yeah.
We did it in 2 long days.
Yeah.
But yeah, it was funny and sad at the same time. But
yeah.
Oh
People
well.
don't realize just how big California is. To go from the Mexican border to Oregon is a
Yeah,
couple of days. Yeah,
spend eternity trying to drive across San Bernardino County,
that's right.
which is, I believe, is the biggest area geographical county in the entire country.
I think it is.
Yeah, yeah, yeah. We have counties here in Utah that are bigger than a lot of the 13 colony states.
I believe it.
Yeah. Anyway,
Elon Musk put out something showing, a small the area of the United States you'd have to cover with solar panels to cover it to supply the U.S. And it is small, but you compare it to the size of Rhode Island, it's still several times the size of Rhode Island.
yeah. Years ago, we used to do. There used to be a thing called the Friendship Cruise, where people would put their powerboat on the Green River at Green River, go down the confluence and up toward Moab. And the area that we had to cover with VHF repeaters was bigger than that of Rhode Island. And the way I did it was I used gas-fed mass-mounted preamps on the receivers that were voting. Then I also ran about 2 kilowatts ERP. And this is all portable. This is stuff this is stuff in the middle of freaking nowhere, on cliffs, in the middle of.
Well, it depends on where you get to put them. That's everything.
Well, let's see here.
All location.
Well, yeah, that does help, but yeah, we had an advantage in that we had geography. Well, geography was both working for us and against us, because the Colorado and Green Rivers are snaking through deep gorges, but we were at another plateau, 1,000 feet above the top of the thing that they were 1,000 feet below. So we were 2,500 feet elevation.
Well, getting down to a canyon will be a challenge, yeah, but in an open desert with mountains, you should be able to go pretty far.
Right. Yeah. Yeah. Just looking here. Let's see here. I just. But let's see here. Oh crap! What did I do with that? I'm just gonna bring that up. Let's see here. So, yeah, here's where receivers were. Oops. And it can't tell easily, but on 3 sides of where I was standing, it's like 1,200 feet down.
Yeah.
So voting receivers and then preamps right at the antennas. And there's an interesting thing too I noticed. So normally, if you get an FM signal on a receiver, when it starts getting weak, you get that popcorn sound.
Right.
As your noise is hitting the limit.
Yeah. Right.
But on these, the gas-fed preamps I built were probably like maybe half a dB noise figure or something. You never got popcorn on weak signals. What you got was they just got steamier and steamier, but you never got popcorn, oddly enough.
I don't believe that. I mean, the popcorn is inherent in FM.
Well, I think what it was though is what we were getting was some probably less of the whatever the shot noise or whatever intrinsic in the detector, and getting more thermal noise from the front end. That was kind of
thermal noise will still give you popcorn. It's just inherent in the mathematics of FM.
Right. But the point is the weak signals with limited by the earth thermal noise sound notably different than they do if you just without the receiver, without the preamp. They sound very different.
I would like to. That doesn't make sense to me.
It could be an artifact of the way the receivers work.
Could be an artifact receivers work, yeah, but an ideal FM detector will still give you popcorn.
Right, but they do sound markedly different. That'd be a good point to know why that is. but they would disappear into steam rather. The signals would disappear in the noise into steam rather than popcorn.
The detector must not have been limiting, maybe, or
I
it
don't know.
must not have been an ideal FM detector responding only to phase.
Well, it was in a RCA Tactic, whatever they used. Probably just a standard chip. You know, probably nothing special, but they did sound oddly different.
Yeah. Well, I mean, there's a very simple theoretical reason why you get popcorn on FM,
Right.
even with thermal noise. It's because, well, the noise is going to be a Gaussian fuzzball if you look at it on an IQ scope. And if that fuzzball extends down and crosses the origin, if it touches the origin, then every time you have a phaser that wraps around the origin, you're going to get a 360-degree phase wrap, which is what you hear as a popcorn pop.
Right.
And that happens more and more often as the signal gets weaker and the center of the fuzzball gets closer to the origin.
Well, I'm wondering if it might have more to do with the way the limiter is working prior to the
That it must not be an ideal FM detector then.
Right, right.
Because an ideal FM detector will sound that way.
So the measured sensitivity of this arrangement was 0.09 microvolts for 12 dB SINAD, and that was that turns out to be very close to what thermally limited.
You mean a 300 Kelvin
Right.
system? Yeah.
Right.
Okay.
Yeah, I calculated the noise floor probably to be about 0.056 microvolts at the receiver inputs after the preamp, something like that. Well, no, no 0.05 at the antenna inputs. And
for whatever the bandwidth is.
yeah, I did the Boltzmann KTB stuff with that, and it came out that way. But then we ran this. Then we ran 300 watts into this antenna, which gave us our 2 kilowatt CRP, and between the two of those, we could efforts. We could hear stations anywhere on the course, no matter where they were, and also assuming the outboard motors are shut off, they could hear us running that much power. Not great in some locations, but
I noticed the generators in that picture.
Well, yeah, our transmitter.
300 watts, you would need it.
Yeah, I mean, the transmitter and keyed up was like 65 amps. I mean, the PA.
Yeah.
So we were charging our batteries 2 and 3 times a day during the busy part of it. But yeah, but anyway, yeah.
I'm familiar with this. I know this popcorn stuff because I was actually getting into FM threshold extension algorithms a while back. I came up with one of my own. I was comparing with the ones that are already known.
Right.
It happens because, like just what I said, when the signal gets weak, the center of the little Gaussian fuzzball gets closer to the origin, and the peaks start wrapping around the origin. As long as the signal is strong, then what you get out is Gaussian. It's just the component of the noise that is perpendicular to the amplitude vector, which affects the phase. But as you get close and close to the origin, the noise is more and more likely to take the phase result around the origin and give you that 360-degree or 2 pi rapid swing in phase, which comes through as popcorn. So the algorithm I was working on was look at the amplitude. Don't limit the signal, but look at the amplitude of the signal. If it's below a certain threshold, just blank it rather than detect it.
Oh, okay.
So take the popcorn as it's like a noise blanker, but a noise blanker is gated by the instantaneous amplitude of the sample. It works. I'm not sure it's any better than the other methods that are out there, but it does work, and it's easy to do with DSP.
The method that I ran that we used for analog satellite was, you're probably familiar with that one. Where
I know NASA did a lot of looking at that in the Apollo days.
So we had Scientific Atlanta receivers, and they had a threshold extension switch.
Right.
And what they did was the LO of the receiver actually tracked the baseband the carrier,
Oh, okay, like a PLL detector.
Right. Then they narrowed the bandwidth down. So
Yes, and track with it. Yes, yeah, that's another one of the
right.
tricks.
Yeah, you got about 2 dB of
That's what you can expect to get. Yeah, about 2 dB threshold extension.
right. And the obvious effect was that if somebody's running multiburst, it didn't look as good when you turn that on, but it looked
Sure.
definitely less noisy. Yeah.
Yeah.
Now, yeah, it would have been interesting in theory to have run, for if one of the next step for like that receiver, if we were still doing that, to get signals even deeper would have been to do something like that on FM, where if the signals are weaker, maybe run it down to like 8 or 9 kilohertz bandwidth and do some gross tracking. Then you could get. I mean, you would trade off distortion a bit, but you could do a bit
But this is really what a PLL detector does, and I'm not sure any of these methods are really even better than a well-tuned PLL.
right.
Now, if you're trying to get good voice at low signal noise ratios, you got to look at RAID. That's Dave Rowe's current project.
Oh, okay. Yeah.
Dave did Codec too. I met him at we had quite a long talk at Pacificon. I went up there and talked to him and heard some. He also gave some talks. He's now published some papers on it, mainly to establish prior art, make sure nobody else can patent this stuff.
Right.
I think it's a game changer. It's a big
So
step in state of the
RAID
art.
is essentially the modem rather than the.
It's combined speech and channel coding.
Oh,
It's a machine learning system where you train it, give it the channel that it's going to have to deal with, a very low signal noise ratio, bandwidth limited channel. And you tell it basically it can send anything it wants over that channel in order to make what comes out the other end sound as much like what goes in as possible. And you train it with about 200 hours of real-time speech, which takes about an hour on a GPU. And the results are just stunning.
hmm.
I mean, you got to listen to some of the demo recordings. Now, when I first heard the demo, I did not know what his peak to average power ratio was, but I know now it's about 1 dB. So he was
Oh,
comparing it to sideband clipped to a 6 dB peak to average power ratio versus a 1 dB PPR RAID signal with the same peak power of 25 watts over a 20-meter channel from Texas to Australia. And the difference is just stunning. I mean, you can barely copy the sideband. You can tell it's in there, very hard to read. And the RAID signal sounds like the reference signal.
oh,
It's like maybe one breakup because of deep fading, and that's it. I mean, it is just stunning.
hmm.
And it's like 800 hertz too. I mean, it's just amazing what you can do with machine learning now. And
Yeah,
now he's working on a version of it for FM, training it to work over an FM channel. We agree it would be better to run, raw RF, but the problem is it's hard to get a linear transmitter on VHF and UHF that fits into a handy talkie because most of them are using non-coherent FM.
right.
But he's got two papers out now he just published. In fact, the reason he came to the US was to deliver one of them the following week. I forget where it was, but it's a open paper. It's on archive.
Okay. I haven't heard so what's the bit rate of the voice codec part? Is it the 700?
Oh, it's not really, it's a combined uh, channel and source coding. So it's analog, it's PCM to PCM.
Okay.
Well, I guess if you want to give it a bit rate, then I would say, let's see, it's 800 hertz channel with a 4 dB signal noise ratio. What's that? We're plugged into the Shannon equation. What do you get for a bit rate? Because what comes out of this thing is a continuously variable signal. I mean, it's time sample, but it's continuously variable in the amplitude domain, except you could quantize it because the signal noise ratio of the channel is only about 4 dB.
Right.
So you can figure out what bit rate that corresponds to. I mean, we've agreed the best way to if you're going to backhaul the signal around your shack, you just treat it as an analog signal and digitize it with, it probably doesn't require more than a couple bits if the gain is set right.
Just you're probably better at pulling the Shannon limit from 4 dB out of your head than I am. Let's see here. Okay. Let's see here. What is it? So how close is it to the Shannon limit?
Well, it's hard to make that comparison because you're talking about human perception. It's not a modem. He thinks that even today, you're probably better off just using the modems that we've already designed because they're already so close to the Shannon limit. What this does is it's the speech coding part. It's the part that, encodes the voice into bits or voice into something that be sent over the channel. In this case, it's merged with the channel encoding.
He's included into this encoding and codec the psychoacoustic properties of the ability of human voice to be lose bits and pieces.
Yeah. I'm not sure exactly what the criterion is for goodness when doing the training, what the objective function is, because that would imply you knowing something about human psychoacoustics.
Right.
I think the way he does it is he actually, what did he do? I think he actually, one of the ways he trained it was by running the received audio into a speech to text conversion and then look to see what the errors were. But that's not a human ear. I mean, it's
right.
It's an artificial ear, artificial hearing. But since it's English or it's human speech, I guess
I mean, I would just think,
principles will be the same.
How would you implement that with a human if you wanted to?
Well, the way traditionally speech codecs have been done is with something called a Moss score.
Yeah.
But that's totally subjective, right? You get a whole bunch of people, and you have them listen to things and you rate them, and it's obviously a very time-consuming, labor-intensive process. That's how codecs have always been developed until now.
Right.
But he has found a way to train these things quickly, and totally automatically, using a graphics card, doing it like 200 times faster in real time. And it's a mixture. I mean, it's not just English. He uses a mixture of languages and voices.
Right.
I'm sure that if you only used English or if you only used a male voice, you would probably get a different set of weights than you would if you did it over, an ensemble.
When I come across a new codec, one of the things I like doing is playing music through it to see the manner in which it breaks down, which is informing.
You mean if it's not designed for music?
Exactly.
Yeah.
I mean, but the way it breaks down is I can kind of get a mental image of how the encoder does what it does.
Oh, sure.
How it breaks down.
Sure.
Right. So yeah, but for that reason, it'd be interesting to see in what manner it breaks down.
By all means, yeah. I mean, he's got code up on GitHub he can play with now.
Yeah.
I want to start doing this because I told him I want to merge it in with KNIQ radio and start monitoring all of the standard frequencies he's using on HF for these modes, so I can just start recording them, maybe form a reverse beacon network for him.
Oh yeah, yeah. I guess.
I think he has a low-speed data channel in there with an ID.
Oh, okay.
So it would make it easy to do spots to PSK reporter.
Okay. Yeah, on a similar thing, I guess Rob was mentioning that the guy that does Sodamate approached you at Pacificon.
Oh, yeah, I think I only talked to him briefly. I didn't really know what he wanted. I got to link up with him again. Is that KD6DM or something?
I think.
So many things are going on at these things that sometimes connections with people fall into the cracks.
Right. I'm looking it up. I let's see here. Yeah, Alpha Bravo 6 Delta. His name is Brian.
Oh, that's somebody else.
Is it? Okay. Well, let's see
I
here.
think so.
Well, let's see here. Sodamate, he's one of the Sodamate guys. There's another 6 call that I've seen associated with it as well. I'm just looking here. But I mean, it'd be interesting to know. I guess what he's been doing is he's been camping a audio channel on the Utah SDR and as a remote receiver and decoding himself. It'd be interesting to know how I guess he could just set up a whatever the codec you use for if it what codec do you use that would support would it support the audio of a busy FT8 channel with all the carriers? Would
Would be for a raw receiver stream?
yes.
I just use PCM
Okay.
because it doesn't have to go very far. I don't need to be efficient.
Right.
And if I was going to send it further, I would just demodulate it first.
Well, I'm curious though, if he were to use a remote receiver, I wonder if would it be more efficient, PCM and decode it at the far end across the internet, or decode every damn transmission that's in that bandwidth, and then send that text.
Well, yeah, sure. If you knew what it was, sure. That's always the most efficient way to do it.
Right. I guess AI6YM maybe. No, I guess Sotomate is A Alpha Bravo 6 Delta. So that's might be the guy that you're talking to, maybe.
Okay. I just posted on the chat group the 2 papers that Dave Rowe wrote.
Oh, okay. I'll take a look at it.
Grab a copy.
Oh, okay. They're actually there. Okay.
Yeah.
Let's see here. I'll put those on.
Yeah, one's for land mobile radio, and the other one is the basic one for HF. Started on HF, and then the land mobile is the second phase of the work.
Yeah, and of course, as you know well, I'm sure that no commercial entity will ever take this stuff and make the code their own and close source it so nobody knows that it's been stolen.
Yeah, well,
I'm sure that never happened to you with your TCP/IP stack or anything else you've done.
Well, but RAID is so totally different. I mean, you would, in order, it would have to be, it would be obvious what it was.
Yeah. Let's see here.
Yeah, check out those 2 papers. This is pretty breakthrough stuff, in my opinion.
Let's see, save. Let's see here. All right. Oh, okay. Huh. Well, cool. All right. Well, it's probably need to go off and do other things for the evening, but always fun.
Yeah, I need to eat.
Yeah, that'd be a nice thing to do. All right.
All right. Always fun talking.
Yep. I guess for some reason when Zoom's up on this computer, it breaks the Windows control bars with minimize and resize on the browser. I don't know why that is.
Oh, I run it on Mac and it seems to behave as expected.
Yeah. Anyway. All right. Well, I'll talk to you later.
All right. See you, Clint.
See you.
So long, everyone. Bye.
Bye. I think I'm in charge here, so it closes. Bye, everybody. Yep. Bye, everybody.